Okay, so looking at some trigonometry problems for finding side lengths. Okay, just some extra problems to be able to revisit. I have 3 examples here of finding all the side lengths, because if you have one side of a triangle, you're able to find 2. So the first thing I want you to remember is if we have this angle 32 degrees and we have a 90-degree angle, that means you also can find out that this is 58 degrees. And the reason that's important is because it gives you perspective. It allows you to use different sort of variations and whatever you might be more comfortable with. So remember, your point of reference is always the angle. Okay, point of reference equals an angle. And it's not the 90-degree angle. It'll be one of the others. So let's go 32 degrees here. This is our point of reference. Okay. I am given the adjacent. This is adjacent to 32 degrees. The x is the opposite. And this is my hypotenuse. So I'm given the adjacent. I'm going to start out, let's finding this one. So opposite over adjacent. Okay, I can't go opposite over hypotenuse because those are both variables. You can't solve a linear equation, a single equation with 2 variables. So I'm going to start with one variable. So the tangent of 32 degrees equals opposite, which is x in this case, over 7. Okay, and now I want to solve for x, so I need to multiply each side by 7 to remove that number, and I get x equals 7 tangent of 32, which is a calculator problem. 7 tangent of 32, 4.4. Okay, 4.4 units. Now, just to show you something really cool, let's say I look at the 58, use the 58 as my point of reference. Okay, now my opposite is 7, my adjacent is x, so it's opposite over adjacent, it's still tangent. Okay, it's now the tangent of 58 equals opposite over adjacent. I need to multiply that up, divide that down, so x equals 7 divided by tangent of 58. If you plug it out in a calculator, you can guess that you are going to get the same exact answer. Okay, 2 different ways to get the same exact answer. So now that we have 4.4 for x, we can go find y. Being we used this as a rounded number, we don't necessarily want to use this one to go find y. Okay, we still want to use our concrete number here. So let's go adjacent over hypotenuse, which is cosine. Cosine of 32 equals adjacent over hypotenuse. Again, you'll learn a trick that when you have a variable on the bottom, you can just flip-flop these entire sections here. So y equals 7 divided by cosine of 32. Calculator problem. 8.3 units. Okay, 8.3 units. I'm rounding to the nearest tenth. I'm guessing it'll be nearest tenth or nearest hundredth in your textbook. Now we're kind of back to decimals. We don't necessarily use the radicals in this case because it's very, very difficult too. Looking at number 2 here, we have the 50-degree angle. I have my opposite looking for my adjacent, so that's going to be tangent. Tangent of 50 equals opposite over adjacent. And then I'm going to set up my equation either opposite over hypotenuse, which is sine 50 equals opposite over hypotenuse. Okay, so I have my 2 equations. Again, we learned that a trick, this can switch with this. So x equals 10 divided by tangent of 50. Calculator problem. And here we're going to have y equals 10 divided by sine of 50. Doing this on the calculator here, I get 8.4. I get 13.1. And that makes sense because y is my hypotenuse. It's opposite to 90-degree angle. Therefore, it has to be the longest side length. These two create the Pythagorean theorem to use that. All right, so a couple more example problems there, and then one more. I have 60-degree angle. Opposite over hypotenuse is going to be sine. Sine of the angle, 60, always based off my angle. Opposite over hypotenuse. And then just because, adjacent over hypotenuse, this is my other angle, cosine of 60. Adjacent over hypotenuse. These ones are quick and easy here. Y equals 15 sine of 60. And x equals 15 cosine of 60. This is 13.0. And 7.5. Okay, so hopefully those help out as points of reference and questions to refer to. Thank you.